Okay, this is Unit 2 review of Matter and Energy, our second unit for AP Chemistry. So matter is defined as anything that takes up space and has mass. This should be familiar to you from Regents Chemistry. There are three states of matter that can exist under normal lab conditions of temperature and pressure, so we are not going to talk about an ionized gas here. The first one is a solid, and then we have liquid, and then we have a gas. In the picture below, you can see how they interact with the container that they are in. There are several different properties that you need to be familiar with for each of the states of matter, which are listed on the next page. Hopefully these should all be familiar to you, but if not, you need to go back and look in your textbook so that you can discuss these things freely. So the things that you need to know are particle organization, meaning are they organized, are they random, do they have a pattern? Particle motion, how do they move, how quickly do they move, what kind of freedom do they have in their motion? Whether they have a definite or indefinite shape, and whether they have a definite or indefinite volume, and then their relative entropy compared to each other. Changes in phase. So we are hopefully very familiar with this heating curve that is down below there. For this heating curve, you should be able to identify during which line segments the kinetic energy is changing, during which line segments the potential energy is changing. What's going on with the particles in each of those line segments if you were to draw a particle diagram to show from the beginning of one segment to the end of the segment what would be different. You should also be able to identify where the boiling point is, freezing point is, condensing point is, and where each of the phases exist. So basically a review of what you would have learned in Regents or Honors Chemistry. So go back if you don't remember this and make sure you know that. Also, you should be able to draw a cooling curve and label that as well and make sure you know all the different points there. Types of matter. So there are several different types that matter can exist in. These should also be a review from previous courses. There are two types of matter. There are substances and then mixtures. Substances are considered pure, meaning they are the same every single time that you see them, and mixtures obviously are not. There are two types of substances, an element and a compound, and there are diagrams for those in this picture. Elements can either exist as just single atoms or they can be multiples of the same atom, but elements have to contain just one type of atom. Compounds, on the other hand, have two or more different atoms chemically combined together in a fixed ratio. So the one that they have there is water, which is H2O. It will always have two H's for every one oxygen. Mixtures. Mixtures contain two or more substances, and you can either have a homogeneous mixture or a heterogeneous mixture. Homogeneous meaning it's the same throughout, heterogeneous meaning there are layers or the composition varies from one place in the mixture to the next. They show you different types of mixtures in terms of what is being mixed together here. So you have mixtures of atoms, mixtures of an element and a compound, mixture of different types of elements. So depending on what your picture illustrates, we'll be able to tell you what kind of mixture or substance you have. On this page, there are several examples of different particle diagrams, and I'd like you to take a few minutes and go through and look at the pictures and identify what you think they are. If you have any questions or you can't figure it out, please make sure that you ask me so that we can make sure everybody's clear on this. But this should be a review, so you shouldn't have too much difficulty with it. I believe you can pause the video and then you can go ahead and practice that. Right, the second topic in this chapter is going to be energy. So first we have the definition of energy. Energy is defined as the capacity for doing work. It exists in several different forms, including chemical, nuclear, electrical, radiant, mechanical, and thermal energy. There are many more forms besides that. Those are the ones that we usually come across. Heat. So heat is defined specifically as the energy that is transferred from one body to another because of the temperature difference, and heat always flows from hot to cold. Enthalpy is the amount of heat that a substance has at a given temperature and pressure. That's the delta H that we use a lot. And temperature. Temperature is another term that we use a lot. It's the measure of the average kinetic energy of the particles of an object. Temperature is not a form of energy, so it does give us a relative scale for how much average kinetic energy the particles in a sample has, but it is not a form of energy. It's not like nuclear or chemical. Calculations. You should go back and review the formulas for heat. If you don't know the formulas for heat, they are on the Regents reference table, which is posted on the website. Please make sure you go back and look at those. They are not in your AP reference table, but you should be familiar with these formulas, so make sure you go back and look at them. I have 2 practice problems here for you. Again, if you could pause the video, try these. I have the answers on the next page so that you can make sure you've done your math correctly. If you're having issues with these calculations, again, please let me know so we can do some practice worksheets. There are the answers. Conservation laws. There are 2 conservation laws that you need to be familiar with. The first one is conservation of energy, meaning energy cannot be created or destroyed, it can just be transferred. This plays a pretty big role when you're doing things like transferring a metal object that's been warmed up into cold water and being able to calculate how much heat the water gained and the metal lost, and knowing that those 2 things should be equal. So that's kind of where that one comes into play. The second one is conservation of mass, meaning no matter can be created or destroyed in a chemical reaction. So this is another important one. You should be able to illustrate the conservation of mass with particle diagrams. You should be able to describe the conservation of mass. And you should be able to do some math problems with conservation of mass, meaning if I tell you you've made 15 grams of product and we started with 5 grams of reactant A, how many grams of reactant B must we have had? So you should be able to do those sorts of problems. Okay, I think that's it, and that's the end of slideshow 2.